like to welcome everybody back to another session of hvaC for beginners. My name is Chris. I'm your HVAC instructor for these videos. Today we are going to go over refrigeration manifolds, and the terminology are used by some technicians out there: refrigeration gauges or hvaC gauges. We have our own nicknames that we give them, but under the actual terminology, they are refrigeration manifolds. We are going to go over in detail. We're going to look at one in person. We're going to go over different aspects, what it does for the service tech, what it's for out there in the HVAC industry. But just a simple breakdown: you hook these up to the suction side and to the high side of your condenser. There are little fittings out there by the valves, and you can hook them up to each side, and you're going to get a pressure reading from your suction side or your low side and a pressure reading from your high side. And what this does, it allows the technician to do some maintenance work or some evaluations on the condition of the unit as it's running in live time. That means that unit's running, it's cooling the house, we're going out, we're hooking up our gauges, and we're going to see if the unit is properly filled with the refrigerant needs by the means of either superheat or subcool. So basically, we're going to find out what condition that unit is at that time of our arrival. And these gauges are just a number of instruments that we use in the HVAC field, but it's one of the most important. Without it, we wouldn't be able to know if the unit is charged properly, if it has the right readings, if there's any flutter in the system, or if there's a restriction. Give you a little jolt of what a restriction is. Say the customer that owns a home hasn't been changing their filter, and they've let it constantly run, and they have a poor habit of changing them. Say you have a 30-day filter, but they've been doing it every 2 or 3 months, and it's been folding it, and dirt bypasses. The evaporator coil will get clogged up. Especially if you have dog hair or dog with long hair that sheds a lot, they tend to get all over the evaporator coil. What that does is it restricts the airflow in time as it constantly keeps going. That dog hair, debris, dirt, and things that come in within the house will collect on that evaporator coil and start reducing the efficiency of the evaporator coil, and eventually it'll start to clog up to the point to where I will get a reduction on my suction side. So I'll give you an example. I've gone out on a call where my suction pressures were 62, but my head pressures were 295. That told me right away that I had a restricted evaporator coil or an extremely dirty air filter. But in both combinations, usually it's both the dirty air filter and a restricted evaporator coil. At some point in time, it will get to the point where there is limited airflow across the evaporator. The temperature of the evaporator will start to drop into the freezing point, and it'll turn that evaporator into a block of ice. Another reason, the cause of one to freeze up, would be low refrigerant charge. So that's where these gauges really come into play as a significant value to you as a homeowner or somebody that's in the HVAC field. Without these gauges, you wouldn't be able to do the job that you need to do. But without further ado, let's go ahead and get to these gauges. Let's take a look at them, and we're going to go over some points on them. The gauges that I'm going to show you and I'll go over, these are called combination gauges, and I'll explain. You'll see why once you get a good reflection or view of the refrigeration manifold. Okay, these are your refrigeration manifolds. These are what we call combination refrigeration manifolds. If you look down below here and follow my pen, you have R22, 404A, and 410A. That means these gauges can be used with these 3 types of freon or refrigerant. These are very popular gauges back in my day. These were made by MRP, but there are several manufacturers out there of refrigeration manifold gauges. You have Yellow Jacket, Robin Air. You have Field Piece actually make them. You can get glycerin filled type, which keeps flutter down from the needles. You can get digital ones, excuse me. You can also get, 4-way manifolds where you can run 2 sets of refrigeration units, or like in the refrigeration world, on one set of gauges. That means it would have 2 of the low side and 2 of the high side. But let's go over in a little bit of detail about these gauges. Now, the handle you see here, and I'm going to roll it over here, these are your manifold handles. This allows you to shut and open the valve of the low side. And what I want you to notice, you'll see a little blue ring in the side of this. I'll tilt it up. If you notice, you'll see a little blue. Okay. This is your suction side, or your low side. It goes from 0 all the way over to 250. And then we will go over the information that you see on the inside. Over here, excuse me, I kind of bumped my camera. Over here is your high side. As you notice, it's red. So it indicates low side and high side in color. It goes from 0 to 800 psi. So this is your low side and your high side. You can always tell because the low side is always going to have the lowest pressure setting at the highest level, and the high side will have the highest pressure setting at the highest level. And these guys are your gauges. Now what I'm going to do is I'm going to lower my camera, and we're going to get as close as I can to the center of your suction side, because you'll be doing a lot of information on this side. All right, let's go ahead and go over suction side of my refrigeration manifold, or refrigeration gauges as you want to call it. I want you to pay attention over here on your right hand side of where my pen is. You're going to see R22, R404A, and R410A. Now, what this means is these are temperature settings for each refrigerant. Okay? All of them. The green is 22, the dark red is 404A, the light red, or what I call pink, is the 410A. At one time they used to do orange, but they went to a lighter color red. But what I want to show you is simple. Not only does this gauge show pressures, as you can see readings by PSI, 0, 50, it also does temperatures, and that's what's important about these gauges here. If you look over here, we're going to start with R22 in the green, because this is where your starting point is. You're going to notice that you have a minus 20 all the way down to looks like almost a minus 30 or an 80. As you go up, you're going to see 0. So this is the freezing point. Okay, below 0, 0 is at the 0 point. As you go up 20 degrees, 30 degrees, 40 degrees, 50 degrees, and so on. Go ahead and look at this one on the 404 side, and the same thing you'll notice. You minus 80, minus 40, minus 20, 0, 10 degrees, 20 degrees, 30 degrees. Over here, the same thing. Minus 80, minus 40, minus 20, minus 0, minus 10. The reason why they're in different areas is because the charge of this refrigerant is done at a different level. R22 has a lower pressure or PSI rating than 410A is. 410A runs higher suction and head pressures than R22 does, and 404 runs a little bit higher than R22 but less than a 410A. But these lines here that are shown right here is what you use to do superheat charging. That means you will take your temperature clamp probe that goes to your meter, you'll clamp it to the suction side, and you'll start to do your readings on superheat, and we'll get into more detail. But what I want to let you do, and what I want to let you know, is it always has to be above 30 degrees. If it is 30 degrees, or basically above 32 if you want to get factor, if it's not above 32 degrees, that coil and the suction line is going to freeze up, and you'll notice it freeze up really quick. Your outdoor temperature is going to factor in where the temperature on like R22 sets and 404 and 410A. The factors are all the same with all refrigerant. Whatever the outdoor ambient temperature is, it's going to have a reflection of what this temperature is and a reflection of your PSI. As temperatures climb, PSI goes up, temperature goes up. So I'll give you an example. If I go out and I come to a customer's home and their system is undercharged, say a pound, and I found a small leak. So I repair the small leak, I go out, I need to charge the system. If it's 80 degrees outside and I do my mathematical equation, and we will be showing you how to do that. There is a mathematical equation. You don't need a slide chart anymore, sling chronometer. Those are from the past. Everything has changed. Everything's moved up into more of an engineering style. So I will give it in a verbal, and then later on we'll actually do it on the whiteboard, and I will show you how to do it. So say it's 80 degrees outside. It's early morning, say 8:30, 9 o'clock in the morning on a summer day. It's 80 degrees. It's a little cooler than normal. I'm going to minus that from a temperature reading of a constant 75 degrees. And that's the number I'm going to use at the beginning. So if I take 80 minus 75, that gives me a 5-degree leftover difference. So I'm going to take that and I'm going to divide it in half. So that's 2.5 degrees. I'm going to go over and I'm going to minus it from 25, and that basically at 2.5, if I take 2 from 25, that's 23. If I take another half, that's 22.5 degrees of superheat. So at 80 degrees, I'm going to use this charging point here, say if it's R22, and I'm going to charge it at a superheat of 22.5. I can do 22.5. It's not going to make really big of a difference. But I'm going to say 22.5. And then basically what it is you're going to have a difference between the suction temperature and the temperature of this gauge should be a 22.5 degree difference. So about 80 degrees, I should be running right around maybe 72, 75 PSI on this gauge, which would put me at about probably 42 degrees across that coil, maybe 45. But as the temperature day goes by, say I'm in the middle of the day, it's 3 o'clock in the afternoon, and it's 100 degrees outside, well, my superheat is going to be different. So I'll give you an example. It's 100 degrees outside. I'm going to minus it from 75. That gives me 25 degree leftover. If I divide that in half, that's 12.5. If I take that away from 25, that leaves me 12.5. So the temperature reading on my suction gauge and the temperature here should be a 12.5 degree difference on R22. And I know it sounds complicated, but I will simplify it later down the road. So we do superheating, but the superheat charge per day will change as temperature rises. So if I did that, I would probably run it around at about 53, 54 degrees, about a head pressure, or a suction pressure, excuse me, of about 82 to 85, maybe a little higher. Just depends on what unit I'm running. But if, say, I was doing 410A and I ran it all the way across on that one and I needed about 50, I would be running between 125 and 130 on PSI, because 410A is an azeotropic mixture refrigerant and it runs higher suction and head pressure. So with that, let's go ahead and I'm going to pull over and we're going to talk about the high side. Okay. Now, same equivalent as to the suction side. Same measurements of your refrigerant. And then if you look at your ranges, it's a little different. This is called subcooling. Okay. You notice it doesn't drop into minus. It starts at 0 across your gauges on the high side. And it goes up to 30 and 60 and 80 and 110. So I'll give you an example. If it's 100 degrees outside, I'm expecting my head pressures to be, anywhere from 225, maybe 230. Sometimes it can be 260. I usually don't like to, but if I did, that would tell me that my high side temperature, if I put my probe on the high side of the line, it's going to be right around at about 110 degrees. Okay. If I do subcool, I'm going to range it. A lot of units like Carrier will actually, on this nomenclature, will give you a subcool range. So I probably want about an 8 degree, maybe a 10 degree difference between the suction temperature and the temperature here. So if it's 100 degrees here, you know, I might be 110 on my high side. But let me be clear, real clear. I always, and I highly recommend, and you can do this, this has been proven time and time again, all the units today, they recommend they want you to subcool. That's fine and dandy. We can do that. But it has been proven in the laboratories, in the universities, and it is proven in the field, because thermal expansion valves have been around a whole lot longer before subcool ever came into the range. We always were taught to superheat because we had flow raters, we had pistons, you had cap tubes, and that's how we did it. Because I have run into a situation in my time where I have subcooled, and there was something wrong with the metering device or the thermal expansion valve, and I had an 8 degree subcool calling, but I had a 28 degree superheat when I should have had a 17. So you can have a foul thermal expansion valve and still get a good reading on your subcool. Always superheat first, because when you're done superheating and you've got it to that point, I promise you, when you go over and check the subcool on your high side, it's going to match to what it's calling for that unit. It's always going to match. So you can superheat. Don't let anybody tell you you cannot, because you can. We were superheating these thermal expansion valves in the field long before subcool was ever put into play. So this is what you need to do, and this is how you do it. But we'll go into more detail. But I wanted to show you what a refrigeration manifold look like, and different, you know, manufacturers that make them. I've had these gauges for, I don't know, 10 years. Now everything's 410. We don't even deal with R22 anymore. It has been removed because of the situation due to the ozone layer. So with that, guys, let me go ahead and pull back. We'll get back to the camera and we'll do a conclusion on it. Well, I hope you get an understanding of what manifold gauges are, kind of what the retrospect of how they are so important in the HVAC field. As you notice, we use it to do superheat and subcooling, pressure measurements. We also use it, this guy right here, for evac or triple evac of your refrigeration system. So we use it to pull 30 inches of mercury down if there's a leak in the system that's significant. And once we fix it, we have to evac the system to remove moisture from the atmosphere using nitrogen. So when you're running it through, I use a triple vac where I will pull a vacuum on it to remove the air. I will then add nitrogen to the system, let it set for a minute. Then I will do another vac. I will add more nitrogen to the system and then do a final evac on it to make sure that I get all moisture out of the system. And then I can open the service valves to allow the refrigerant that I have pumped down into the compressor and let it flow through the system for a minute, let it balance out, and then I can go in and do my superheat charge for that customer's AC system. But we will go over in more detail. I know that was a lot to absorb, and I apologize if it kind of throws you off. We will get to the mathematical part on how to superheat. It is really simple. When I tell you I use 75 as a beginning number and 25 as my secondary number, that means at 75 degrees ambient temperature outside, the superheat is 25. That's 100% of a charge. So that's the starting point, and it was developed by a professor over at Southern Methodist University, and then it was picked up by other professors from TCU and on down the line, and it is being used out in the field quite a bit nowadays. There was a service manager I used to work for Hightower Service. His name was Mike. He was real adamant about it, and I already knew how the process worked, and I also taught it to my students when I was teaching, and we rely on it, and they rely on it quite well. I still hear from those students to this day and how grateful they are learning it and how quick and how reliable that method is. But with that, guys, we will get to you on the next video. We're going to go over to part 2 of the gas furnace and air handler and kind of break down the detailed parts in it. It's going to take me a little longer. It will be a little longer video than the other ones, because we will be going over piece by piece the important parts of your gas furnace and your air handler. And we will go over a little bit on the air handler on the kW type strips that are in it, the 5, 10, 15, and 20 kW and higher. We will go over those and kind of get a breakdown, and we will go into the next phase, and I will show you how to do an amp measurement per heat strip on that, so you know what type of breaker will be used with that. Guys, I enjoyed doing this video with you. I hope you see me on the next video. Hit the subscribe button. Hit that notification bell so you get notified for every video I have. Hit that like button. It really helps the algorithm. Lets YouTube know that you're wanting to see more of my videos. With that, guys, this is Chris with the hvaC for Beginners. We'll see you on the next video.